Hi, myself Dr. Pranesh, Assistant Professor, Department of Mechanical Engineering, Sri Ramakrishna Engineering College. I am happy to welcome you all for the next session on friction. In today's lecture, we will see what is meant by friction, types of friction, application of friction. Let us move on to the session. Friction. What is meant by friction? Very simple example is rubbing of our hands. Friction is the resistance of motion of one object moving relative to other. That is, when two surfaces are in contact with each other and one surface tends to move with respect to the other, a tangential force, which is very important, tangential force will be developed at the contact surface in the opposite direction of motion. For example, consider an object placed over the horizontal surface and I am giving force in this direction to the object. What will happen? This will tend to move from left to right, but the friction on the surface will try to act in the opposite direction of motion. So, this is the simple example of friction. And one more thing, this tangential force we can call it as frictional force, or we can simply call it as friction. Next, types of friction. So, there are variety of types are there with respect to static friction and dynamic friction, third one rolling friction, and fourth one fluid friction. First, a basic thing is static friction. Very simple example is pushing a wall. So, at that point your wall is in the static condition, that is at rest. And next is dynamic, we are moving, that is slipping on wet floor during movement. And third one is riding a bicycle, and fourth one is swimming. And a basic type is first one dry friction and second one is fluid friction. Dry friction is the force that opposes one solid surface sliding across another solid surface. And next is of fluid friction, and whoever is swimming, they can feel this friction, that is fluid friction occurs between fluid layers that are moving relative to each other. This internal resistance to flow we can call as viscosity. And another type of broad classification is, another type is dry friction. The dry friction is of two types, static friction and dynamic friction. What is meant by static friction? Which is at rest. So, static friction is the friction experienced by a body during rest. And dynamic, there are two types, kinematics and kinetic. Kinematics without considering force and kinetic is with considering force. So, the dynamic friction is the friction experienced by a body during motion. And in that dynamic friction, another two types are there. First is sliding and another one is of rolling friction. Initially we saw those types. With respect to definition, sliding friction is the friction experienced by a body when it slides over another, and rolling friction is the friction experienced by a body when it rolls over a surface. We will enter into the topic on limiting friction. What is meant by limiting friction? Consider an object M. I am applying force in this direction. What will happen? This will try to move, but the frictional force opposes this movement. So, the frictional force always acts in the opposite direction of motion. But by default we know that self weight will act in the downward direction. Reaction force, that is normal, will act in the opposite direction of your self weight. So, the limiting friction normally we will call it as mu r n. Okay. So, the definition is the maximum friction force that can be developed at the contact surface when the body is just on the point of moving is called limiting force of friction. The maximum resistance offered by a body is called limiting friction, a simple definition for the limiting friction. Now, next is coefficient of friction and angle of friction. What is mean by coefficient of friction? The ratio of limiting friction to the normal reaction is known as coefficient of friction. Limiting friction to the normal reaction. Okay. And next is angle of friction. What is an angle of friction? The angle between resultant and the normal. Angle between these two. We can call it as angle of friction psi. So, the angle between resultant and the normal reaction is angle of friction. Next, in this there are two types of coefficient of friction is there. One is of static and another one is dynamic. We will call it as coefficient of friction with respect to static, and dynamic states we can call it as mu suffix s as well as mu suffix k. And next, what is mean by impending? Impending is nothing but the state of motion of a body which is just to move or slide is called impending motion. So, when the maximum frictional force, that is of limiting friction, is attained, what will happen? And if the applied force exceeds the limiting friction, the body will start move or start sliding or rolling. This state we are calling it as impending motion. We will see the examples, the cases. Case 1, a basic condition is, suppose consider there is no friction, there is an object, okay, over the horizontal surface. By default we know the self weight will act in this direction, and opposite to the self weight is your normal reaction will act. If there is no friction, what will happen? How to resolve this? It is in the equilibrium condition. If it is in the equilibrium condition, you need to apply the equations, that is summation of h is equal to 0 and summation of v equal to 0. Here there is no horizontal force, right? So, you leave this equation. Next is summation of v equal to 0. We have W one vertical force and NR opposite force. Suppose if you are considering the force which is acting upward is positive, the force which is acting is downward is negative, and the horizontal force is positive, horizontal this direction is negative. Accordingly, if you are following this, you take NR, okay, N suffix R, suppose positive, minus W equal to 0. So, if you equate this, we will get NR equal to W. Similarly, for the next case, that is if your friction is less than the limiting friction, what will happen? Now, I am applying again, the object will be in the equilibrium condition. Why? Because you are applying a force with respect to horizontal inclination theta. What will happen? Friction will develop. This force should exceed this frictional force, then only this object will move, or else what will happen? Again it will be in the equilibrium condition. So, you need to draw the free body diagram. Vertical forces, what are directly involving forces? Self weight, normal is there, the force P you are applying will act with respect to horizontal, so cos theta, and opposite is your F. Suppose here you are applying summation of h is equal to 0, summation of v equal to 0, horizontal you will get this equation, and vertical you will get this equation. So, we know that horizontal with respect to horizontal force is P cos theta, and with respect to vertical is P sin theta, and depending upon the sign how you are applying, as we saw in the last case, upward positive, downward negative, accordingly that condition you need to specify, and if you solve again with respect to it is in equilibrium condition, so horizontal and vertical you will get it, you can solve. And the third case, if the F equal to Fm, friction is equal to limiting friction, again your object is in static condition. So, what will happen? Again you need to apply summation of h is equal to 0. So, summation of v equal to 0, you will get limiting friction is with respect to P cos theta, and if you are applying summation of v, you will get NR equal to W plus P sin theta. Okay. So, this 1, 2 and 3, because of inclined force we can resolve with respect to her vertical and horizontal cases. So, P cos theta and P sin theta. So, this is P sin theta and this is P cos theta. Suppose this force is acting from right to left, minus. This is acting from top to bottom, minus, or plus, depending upon the case how we are solving. And the third one is this equation also we can apply, that is coefficient of friction is nothing but limiting friction to normal. Fine. Then what is the fourth case? If the object is start moving, if the F is greater than Fm, so that what will happen? Here the equation of equilibrium cannot be applied because the object is in moving condition. So, only the dynamic case we can apply. So, this denotes the dynamic condition. So, here, so what will happen next is with respect to vertical, you can apply, you will get the case as nr equal to w plus p sin theta. So, this object tends to move, here your equilibrium condition cannot be applied. That is the difference with respect to those four cases. Next, angle of repose. What is mean by angle of repose? What this angle of repose says? Consider an object which is with respect to horizontal alpha is there. Okay. So, if it is of inclined in nature, we know that two components will comes into picture, w cos theta and w cos alpha and w sin alpha will comes into the picture. Because of inclined, we know that two components will comes. If you are applying horizontal summation of h is equal to 0, v equal to 0, because it is not in equilibrium condition. Okay. So, what will happen? This object is tends to move. So, this first equation you will get it, nr equal to w cos alpha, and next you are applying second cases, F is equal, that is coefficient of friction is nothing but limiting friction to normal reaction. And if your object is in equilibrium, how about the case your mu cos alpha is greater than w sin alpha, means this object will not move in this direction. So, what will happen where this is greater than this? So, this object stays on the inclined condition itself. If this mu w cos alpha is less than w sin alpha, okay, if it is less than w sin alpha, what will happen? This object will tends to move in the downward direction. So, these two cases plays a vital role. So, if it is in equilibrium means your mu cos alpha is greater than w sin alpha. So, it stays on the same point. If your mu w cos alpha is less than w sin alpha, what will happen? The impending motion takes place. So, the object will move in the downward direction. So, the angle of inclined plane at which the body tends to slide down is known as angle of repose. So, we can call it as angle of repose is equal to angle of static friction. We will see the engineering application, that is of ladder. Normally, everybody we will use ladder to climb the wall or the staircase or whatever it may be. Assume this is the condition. Now, consider an ladder like this is leaning against the wall and the floor. So, this is floor and this is the wall, floor and wall. So, what will happen? If there is no friction at this portion and there is no friction at this point, what will happen? This ladder will start moving in these two directions. If it is on the floor leaning against the wall and both the ends, if there is no friction, what will happen? This ladder will start moving in these two directions. But we have a friction. What will happen? This will not move, right. So, first condition is assume that there is no friction on both ends, this will start moving. Second condition is you assume there is friction at both the ends. What will happen? This, that is the object, for example, in the bottom or in the top, first we need to specify what all the forces are acting. That is, if this is the movement, what will happen? The friction will takes place in the opposite direction and normal is also there in this portion. And consider at point B, if there is no friction, or if there is, for example, if you consider there is a friction at point B, first one you need to consider this normal, that is n suffix b, and this f suffix b you need to consider. Why? Because the movement of ladder is in this direction, so the frictional force will takes place in the opposite direction. And if suppose the movement is taking place in this direction, your frictional force will takes place in the opposite direction. So, this NA and FA, NB, FB you need to mark. Now, if suppose an object and man is standing at the midpoint of the ladder, we need to consider that portions, that weight as well as the self weight of this ladder we need to consider. So, normally at the bottom how many forces? FA is there and the NA. In the top FB is there and then NB is there. So, this FB how to relate? We know that mu suffix A is nothing but limiting friction by normal reaction. So, this can be solved by means of three equations, that is summation of H is equal to 0, V equal to 0, moment equal to 0, and in addition that coefficient of friction also we can use. We will see one of the case how to solve this. Consider a uniform ladder of weight 1000 Newton and of length 4 meter rests on a horizontal ground and leans against a smooth vertical wall. The ladder makes an angle of 60 degree with horizontal. So, that is ladder makes 60 degree with respect to horizontal. So, this is 60 degree with respect to horizontal. When a man of weight 750 Newton stands on the ladder at a distance 3 meter from the top, from here it is of 3 meter. So, this distance is 3 meter. The ladder is at the point of sliding. What is happening? A man of weight 750 Newton stands on the ladder at a distance of 3 meter from the top of the ladder. At the time the ladder is at the point of sliding. Determine the coefficient of friction between the ladder and the floor, that is mu we need to calculate, that is Fm by normal reaction. This coefficient of friction mu we need to calculate. Let us see how to solve this. So, first you at the bottom consider, so based on the question they told that horizontal ground and leaning against the smooth vertical wall. So, because of smooth condition here there is no friction. So, only at the bottom there is friction. So, if it starts sliding, what will happen? This will move in this direction and the frictional force will takes place in the opposite direction. So, this friction is there, this normal is there. We have to mark this first. And at the top only because there is no friction, because of smooth wall, this is the clue, smooth vertical wall. So, only your normal will comes into the picture. Okay. So, first condition is FA equal to mu A into NA. So, what will happen in this case? Because of friction at the bottom, this alone will comes into the picture, and at the point B there is no friction. So, simply you need to mention FB equal to 0. So, this condition is there, this is not there first. So, first is okay. Next, what is the second case? What we have to do? Next, we need to summation of V. So, you can start with summation of V. What is mean by how many vertical forces are there? First consider the vertical and then if required we will move on to horizontal cases. So, summation of V. How many horizontal force is there? this NA, sorry, vertical force. How many vertical force is there? NA is there, and then this self weight is there, W, and then man's weight is there, 750 Newton. Okay. So, 3 vertical forces. NA you can consider, that is upward force positive, and then downward is negative, another downward is negative. We are equating and we got NA term here. Next, what is the another available term? We know that once vertical is over, next with respect to horizontal. First vertical over, next I am coming to horizontal. Horizontal only NB is there, first one in the top, and another picture we have FA is there, FA in the opposite direction. So, we will get NB equal to FA, that is mu is nothing but FA by NA. So, here instead of we need FA, so I can write like this, FA is nothing but mu A into NA. NA what we found? It has 1750 we found. So, you can substitute and you can get the terms. Okay. So, now summation of H and summation of V over. Next, I am coming to moment, because upon using summation of H and V, it is not possible to get the term. Why? Because in order to get the coefficient of friction, we need both F as well as N we need with respect to ladder and the floor, the bottom. So, now with respect to moment, so where I am taking moment? I am taking moment at the bottom. I am taking moment at the bottom, at point A I am taking moment. So, what will happen? Horizontal force, this NB. So, moment is nothing but force into the perpendicular distance. Okay, force into perpendicular distance. So, the force is NB, the perpendicular distance is your B to G. NB into BG. So, first one over, and another what is there? 1000 is the vertical force, and perpendicular distance is your A and F. Perpendicular distance is A and F, and this is A is your reference point. So, this NB which is moving in clockwise direction, so it is positive. So, we already discussed this is positive, I am considering like this. So, this is positive and this is negative. Similarly, your clockwise is positive, counterclockwise is negative. So, first case is NB into BG is clockwise, and 1000 into AF is counterclockwise to reach A, and the third case is this 750 into this distance from here to here, that is we can mention as A to E. Okay. So, 750 into AE equal to 0. We are equating this moment equation. So, first we apply summation of V equal to 0, we applied summation of H is equal to 0, and third one we are applying moment equal to 0 at point A. Not only point A, you can apply moment at B also, nothing wrong. Okay. So, if you solve this, you will get the BG distance. What is meant by this? Height, you will BG, height you will get it. Okay. And then AF distance we will get it, and AE distance we will get it. So, if you substitute all the three in this case, we will get mu and NB, that is NB as 397 N, okay, and then mu A equal to 0.226. So, what they have asked, determine the coefficient of friction between the ladder and the floor is 0.226. So, this is the one of the application of friction. So, I hope you enjoyed the session on friction, basics of friction we saw, types of friction we saw, and one application with respect to ladder friction we saw. Thank you.